Ever wondered what happens under the hood when you turn on your car? Well, it's like an orchestra, a symphony of mechanical parts working in harmony to get you from point A to point B. The car engine, the conductor of this symphony, is a complex machine made up of many key components that all play crucial roles. To start, we have the cylinder block, the main housing of the engine's cylinders, providing support and structure to the engine components. Inside these cylinders, we find the pistons, the hard-working maestros moving up and down, driving the engine's crankshaft. Then we have the camshafts and valves, the rhythm section if you will, controlling the opening and closing of the intake and exhaust valves, ensuring proper combustion and engine performance. Lastly, we'll delve into the cylinder head, fuel system, air intake system, and exhaust system, each a vital part of this mechanical ensemble. So, buckle up as we take a deep dive into the world of car engines. The cylinder block is often referred to as the engine's heart. And there's a good reason for that. This robust structure provides the essential housing for the engine's cylinders, but it's more than just a protective shell. The cylinder block plays a crucial role in the overall function and performance of the engine. Imagine the cylinder block as a bustling city, with each component representing a different building or institution. The cylinders are like skyscrapers, reaching up towards the sky. Pistons, the city's workforce, move tirelessly up and down these skyscrapers. The crankshaft, the city's transportation system, converts all that vertical movement into something more useful, rotational motion. But none of this would be possible without the cylinder block. It provides the foundation for this metropolis of movement and power. It supports and structures the engine, allowing each component to perform its function with precision and efficiency. Without the cylinder block, the other components wouldn't have a place to call home. The cylinders are where the magic of combustion happens. Picture a chamber, a stage if you will, where a highly choreographed dance of fuel and fire takes place. This is the cylinder, the heart of any engine. It's here where fuel and air mix and ignite, releasing energy that powers your car forward. Now, cylinders can come in different arrangements, each with its own unique characteristics. You've got your inline engines, with cylinders arranged in a neat row. Compact and efficient, these are common in smaller vehicles. Next up, we have the V engines, where cylinders are set in two lines forming a V. Offering more power in a smaller space, you'll find these in high performance and luxury cars. And then there's the boxer engine, with cylinders laid flat facing each other. Renowned for their balance and smooth operation, these are favored in sports cars. So whether it's an inline, a V, or a boxer, remember this: the cylinders are the stage where the combustion drama unfolds. Now, let's talk about the pistons and crankshaft, the movers and shakers of the engine. Our journey starts inside the cylinder, where the piston, a cylindrical component, resides. Now, imagine a plunger moving up and down in a syringe. That's how a piston moves inside the cylinder. This movement is facilitated by the combustion of fuel, and it's this up and down motion that forms the very heartbeat of your car's engine. But how does this up and down movement of the pistons drive the car? Enter the crankshaft. The pistons are connected to the crankshaft via connecting rods. Picture a bicycle pedal system. As you push down on the pedal, the crank connected to the pedal turns, spinning the bicycle's wheel. The same principle applies here. The pistons, acting like your feet on the pedals, push down, causing the crankshaft to turn. This transformation of linear motion of the pistons into rotational motion by the crankshaft is one of the wonders of mechanical engineering. It's the same concept that helped humans harness the power of steam in locomotives during the Industrial Revolution. And it's this rotational motion of the crankshaft that ultimately drives the wheels of your car. So, in essence, the pistons and crankshaft work together like dance partners in a beautifully choreographed mechanical ballet. The pistons, fueled by the controlled explosion of fuel, move up and down in the cylinders. This movement is transferred to the crankshaft, which spins, turning the energy from the pistons into a force that propels the car forward. So when you step on the gas pedal, you're not just making the car go faster. You're setting off a chain reaction that starts with the pistons moving faster and ends with the crankshaft spinning faster, driving the wheels at a higher speed. The pistons and crankshaft together create the motion that powers your car. It's a system as elegant as it is powerful, a testament to the ingenuity of mechanical engineering. Camshafts and valves control the rhythm of the engine. This is where the magic of timing and control truly comes into play. Picture a conductor leading an orchestra, dictating the tempo, ensuring every instrument plays at the right time. In our engine orchestra, the camshafts and valves are the conductors. The camshafts, through a series of lobes or cams, control the opening and closing of the intake and exhaust valves. Each cam on the camshaft is designed and shaped to open a valve at a specific time, hold it open for a certain duration, and then close it again. This dance is choreographed down to the millisecond, ensuring that each valve opens and closes at exactly the right moment in the engine cycle. Now, let's talk about the valves. They're like the gates of a city, regulating the inflow of fresh air and fuel into the cylinders and the outflow of exhaust gases. The intake valves allow air and fuel into the cylinder for combustion, while the exhaust valves expel the burnt gases after combustion. The camshaft, with its precisely designed cams, controls these valves. When a cam pushes against a valve, it opens, allowing either the intake of air and fuel or the expulsion of exhaust gases. The valve then closes when the cam rotates away, ensuring no unwanted exchange occurs. This synchronization between the camshaft and the valves is crucial for optimal engine performance. Now, you may wonder, why is this timing so important? Well, improper timing can lead to a number of issues, including poor fuel efficiency, reduced power output, and even engine damage. Imagine a symphony where the instruments are out of sync. The result would be far from harmonious, right? Similarly, if the valves open or close too early or too late, the engine won't run smoothly and its performance will suffer. So, you see, the camshafts and valves play a vital role in the operation of an engine. They control the flow, the timing, and the rhythm, ensuring that everything works in harmony. The camshafts and valves, they're the conductors of the engine orchestra. The cylinder head, fuel system, air intake system, and exhaust system complete the engine puzzle. Let's delve into how these integral components work together to keep your engine running smoothly. The cylinder head is the unsung hero of the engine. Sitting atop the cylinder block, it serves as a housing unit for several key components like the intake and exhaust valves and the camshafts. The cylinder head is also home to the combustion chamber and contains intake and exhaust ports. It's like the conductor of an orchestra, managing the flow of air and fuel into the cylinders while also controlling the exit of exhaust gases. Moving on to the fuel system, it's a lot like our body's circulatory system, but instead of blood, it pumps fuel. This system includes the fuel tank, fuel pump, and fuel injectors or carburetors in older models. The fuel system's main job is to deliver the right amount of fuel to the engine at the right time for combustion. It's a delicate balancing act that requires precision and timing. Next up, we have the air intake system. Like a deep breath before a long run, the air intake system supplies the engine with the air it needs for the combustion process. It encompasses the air filter, throttle body, and intake manifold. The air filter ensures that the air entering the system is clean and free from debris. The throttle body then regulates the quantity of air entering the engine, while the intake manifold distributes this air evenly to the cylinders. Finally, we come to the exhaust system. Once combustion has taken place, it's the exhaust system's job to effectively remove the exhaust gases from the engine. This system includes the exhaust manifold, catalytic converter, and muffler. Not only does it ensure a safe and efficient exit of exhaust gases, but it also reduces the noise produced by the engine. These components work in harmony to ensure your engine runs smoothly and efficiently. They each play a unique part in the engine's symphony, creating a masterpiece of mechanical engineering. So, that's the intricate world of car engines for you. We have explored the heart of the engine, the cylinder block providing support and structure for the engine components. We've traversed the combustion chambers, also known as cylinders, where the magic of combustion occurs. We've dived into the world of pistons, the cylindrical components that drive the engine's crankshaft, and the crankshaft itself, which converts that up and down motion into rotational movement. We've discovered the role of camshafts and valves, key controllers governing the opening and closing of the intake and exhaust valves. We've looked at the cylinder head that houses these components, as well as the fuel system delivering fuel for combustion, the air intake system supplying necessary air, and the exhaust system ensuring the removal of exhaust gases. Each component plays a crucial role in the overall functioning of the engine. Next time you start your car, you'll know what's happening under the hood. Until then, keep exploring the fascinating world of mechanics.